This is not working for me.
What?
I need to stew this over again. Something's off.
Something's off.
Let me see. Oh my gosh, yes. What is going on? Hello and welcome to Chemists in the Kitchen. Today we are going to be looking at boba tea. And in particular, we're going to be making the tapioca pearls that give boba tea their unique texture and flavor. So we'll be making it from tapioca starch, and we're going to be varying the temperature of the water to see what makes the pearls perfect.
Hi, my name is Adrian DeFonte, and I'm a physical chemist, and I work for a medical device company.
Hi, everybody. My name is Daisy. I am a chemist, and I work in soil science.
Hi, I'm Julie Pollack, and I am an associate professor of chemistry at the University of Richmond. We're gonna get going by boiling some water to make some brown sugar syrup. So we're gonna take 3 cups of water and add it to a pot to start boiling.
Actually, in my neighborhood, there's about 10 different boba places within 5 minutes of where I walk, so it's very accessible to me. But my favorite thing about boba is just that very soft, squishy texture that mixes in with the tea that you're drinking. And I don't know what you guys experience when you're having boba tea.
So I will tell you, this is going to be my first experience drinking boba tea.
Party balloons.
I'm excited to try it, and maybe I will find my new second favorite drink. So Daisy, why is boba your second favorite drink?
I first tried boba in high school. We used to have these multicultural fairs, and several clubs would bring in boba drinks to sell to raise money for their club. So since then, I was kind of hooked. I love the texture. We would also actually throw little boba pearls like through the straw into the tennis court. The structure of what is this tapioca starch is really the thing that's going to help us to be able to form the pearls. So this is a glucose molecule. This is a basic sugar. It has 6 carbons in it. You can see them labeled in purple, 1, 2, 3, 4, 5, and 6. And there's a bunch of OHs on it. And those OHs are what can interact with water very well. So these glucose molecules get incorporated into what are called polysaccharides, which are just polymers or a bunch of glucose units all connected onto one another. So amylose is what is called a linear polysaccharide. So it is all of the glucose molecules linked in what is called an alpha 1,4 linkage for long strains. They are somewhere between usually 100 to 1,000 units of glucose in an amylose strand. There is what's called amylopectin, which has a very similar structure. Essentially, this starch is just a bunch of glucose molecules all bonded together in this very interesting way.
When you look at it, everybody just looks at it as powder. But really, I think what Julie is trying to get the concept across is that there's these long strands and these long chains that give rise to the structure that we're about to make.
1 cup of brown sugar, right, to our boiling water, and we're going to reduce it down to a syrup.
There's only really 2 ingredients. The rest are all things that you're adding into the system for flavor and for experience, or like for taste. When we first started, we want to talk about a little about temperature. That is kind of the variable that we're adjusting here to get to the end result, to show you and demonstrate how this powder with this mixture of water actually forms into this texture that's different from the 2 initial ingredients.
Yeah, so let's start testing with the cold water to see what, just cold water does when we introduce it to the tapioca flour. And we'll kind of see that, let's make that as like our 0 point, then compare it as we begin actually making our boba pearls in hot water.
All right, so we're gonna take 6 teaspoons of the tapioca flour, tapioca starch into a little bowl.
Which is like kind of crazy because it's really not that much.
I know. And then we're gonna do 2 teaspoons of cold water, right?
Ratio is 6 to 1.
6 to 2, 6 to 2.
I already see something very interesting.
It looks like glue?
It looks like glue, but some of it looks like oobleck. So it's like soft if it moves, but if I hit it, it like stops.
Mine now that...
Oh no, is
yours still
great.
like that, Daisy, or is it now just like straight up hard? Because mine is like straight up hard now.
Yeah, mine's not working very well. I can tell you that much.
What do you mean not?
I would not recommend making boba with cold water.
I just find this interesting from a soft matter physics point of view. There's this texture to me that we have here. Definitely, it's not holding up. There's very minimal structure.
Yep.
It does tell me that when we think about temperature, it has to kind of activate something and get stuff moving around. And at this temperature, things are not moving around in order to set up some kind of structure.
Yeah, the starch is very rigid, right? Because like you need heat to make molecules move. And in this case, the cold water just was like, and it's just stuck there.
Yep.
I think is a good word. It's like, ugh.
Yeah.
It's just,
All right, two teaspoons on top of the other ones.
Yes.
And then mix, mix, mix as quick as can, right?
Yeah.
I think. Oh my gosh.
I'm assuming we're mixing to get the molecules to move really fast.
Yes.
Oh, this looks better.
Yeah, it's definitely coming together as more of a dough here.
Oh wait, mine's
me.
like very ooblecky.
Yeah, mine is definitely more like ooblecky too. It's coming together.
So I can shape this and then it relaxes.
You can actually see it relax over time as the shape actually and the height decreases.
And I think maybe, Daisy, you need more starch.
Yes, that's what I'm doing. Okay, it's getting better.
Look,
You got a rope.
I've got a rope.
You know what's funny? She's like, this is the first time I've ever done this. And then she's like, look at
Here
this.
we
Look what
go.
I've done.
We're
I also
so
make
bad.
a lot of breads. So like, I feel like when it comes to making a dough, I do enjoy making dough.
Too much.
This won't be so bad. This will be easy.
Exactly.
There's only 2 ingredients.
You making it, Adrian?
Yeah, I think I got it. I did. It's very soft, like it relaxes.
Yeah.
So you have to make them like a little bit smaller because they'll fall apart it'll flow on its own weight.
We're supposed to be making it into our balls once you're there.
Yeah.
But what size is the ball supposed to be?
I don't know. It does.
Like 1 centimeter ball? Like, is that seems big. That seems big though. I feel like it needs to be smaller.
Gotta be gentle. I have to remember, like you said, gotta be gentle. It looks like a tiny tooth.
Yeah.
Yeah.
I'm going back to
I
the
think that's
cold
right.
one, by
That
the way.
looks right.
We have to, there is a size limit because its own weight, it will collapse under its own weight. So if we make them small, they'll hold a little bit more structure in terms of like a sphere.
I have about 50 little balls in mine.
50?
50. 50.
What the heck? I don't understand. What are you doing back there?
That's what I got. That's what I got.
You know what? Okay, also Daisy, I think she prepared this and she had that underneath somewhere. And she's like, look, I did this already.
I promise. Did you add it, Adrian?
I'm going to right now.
Okay.
I added
Adding
one.
it.
There we go.
I'm adding 1. Ooh, it fizzled.
I'm adding them all in.
Are you dropping them?
Okay. Yeah.
I'm dropping them in, yes.
We're at 10 seconds, so I don't know.
What happens when you drop them in?
I will
Mine
take it
didn't
out.
really have any.
It's
Oh,
bubbling. Do you see bubbling?
Oh.
mine?
Yeah, mine did.
I mean, there's like a little bit of a bubble just from like something dropping in it, but
Yeah.
I got some that are floating.
Me
It's
too.
It's been a minute. Okay.
1
All
minute.
right. Ooh. So
Oh,
it's definitely gooey.
there's gooey
Eh,
and chewy.
It's gooey. It's squishy. It squishes easily.
Yeah.
Yeah.
I mean, it's definitely tastes. I mean,
It tastes like
the
boba.
texture is not the same. It's definitely cooking on the outside. It's definitely getting squishier as opposed to it was like crumbly. I wish I had kept one out. I didn't keep one out.
I kept a.
Wait,
a
hold on. I
dry
have
one.
another one. To be able to compare these things.
I'm comparing them. I'm putting
I know,
them.
Daisy, you're a very good scientist. I know it when I'm on these things with you. You're a very good scientist. All right, I gotta pull another one out. That's my 2-minute test here.
5 minute
All
mark?
right, yeah, 5 minutes, Adrian.
Yep.
Okay.
5 minute.
I'm picking one up.
Let me see.
Whoa, this one's still very chewy.
Mine is less squishy.
Yeah.
Less squishy. Oh my gosh, it's like bouncy.
Elastic.
Oh my gosh, this is so cool. It also tastes good because of the brown sugar.
Yes.
It's so interesting as it's absorbing that water. The texture, I would say the texture changed remarkably between
Yes.
kind of a little bit dry, crumbly
Yep.
before it went in the water and like pretty immediately, like as soon as I took out the first one, the texture of the outside had changed. Now
Yeah.
I feel like that squishiness, the water has permeated into the polymer chains.
It's more inside. It's making its way to the center.
So what's happening is it's swelling, right? And it's not swelling a lot. Like it's still pretty, I would say, yeah, it's about the same size. I don't think it's gotten much bigger necessarily, but it is starting to for sure absorb more into it. That's changing the texture, absorb more water into it, excuse me, to do that. It's supposed to turn translucent, which I would say it actually is starting to look a little bit more translucent to me. If you look at yours, does it look more translucent to you guys?
From T1 to T5, definitely more translucent.
Yeah.
I'm trying to mix them in here. It's getting much more uniform.
Yeah.
So like squishiness ability, biology here. It feels a little harder.
Yeah.
So as they cool down, they get a little bit harder.
Yeah, they get harder and they also change their color. But what you'll also observe there is that there's actually air bubbles trapped inside. And so that kneading and mixing that we had wasn't really well distributed. And so when you heat it and started to cook everything, it locked all the stuff inside as well, which including air. But I see pockets, and so that's why it's not completely transparent. Because those air pockets are actually trapped inside as well.
I don't think I have any air bubbles.
I do.
Again, Julie, I know you got this.
No, I'm just saying, I'm not sure I see any air bubbles. Okay, so what type of tea are you making?
I am making a green tea mango. So I made a mango syrup beforehand.
What?
Yeah.
Daisy,
Come on.
you are too fancy. I'm not
Folks.
gonna lie, you're too fancy, Daisy. You're always taking it to the next level.
It's not some regular folk. I was just doing some Earl Grey because I wasn't thinking too much. Yes.
I got vanilla chai because I'm not a huge tea fan, but so there's like extra spices and things like that into it to give it the chai flavor. Okay, all right, let's pull out our 20-minute ones. I don't feel like mine have changed much from my
10-minute mark one.
my 10-minute mark. It looks about the same.
Yeah. It feels
Okay.
about
All right. Feels
a little. It's a softer.
squishy.
It's a little squishier.
Softer?
Yeah.
Does it feel like how boba's supposed to feel like?
Yeah. Yeah. It's maybe like a tad harder. I know.
I'm gonna put this in my tea if you guys
So I
want.
got my bobas in
Yeah.
my brown sugar syrup like this. Is that what
I
you
have
got?
something like that. Something like
Okay,
that.
then
Yeah.
I'm adding some almond milk to mine.
This is mine.
All right, then I got my big old boba straw.
Make sure you get one in
All
the
right, wait,
straw.
cheers. We gotta cheers first.
Oh,
This
okay.
is a drink. We gotta cheers, y'all.
Just
Cheers
make sure
to
you-
Chemists in the Kitchen.
You have to look
Cheers.
everybody in the eye. Tastes good.
Oh,
That one,
one of them is still extra chewy.
are they supposed to be chewy? Mine are chewy.
Some
Yeah.
are soft and some are harder. They're only like a tad chewier than like the ones that I go get, but it was pretty good.
It tastes good. I like it.
It does taste good. The sugar water, the brown syrup sugar water, really makes that. It is that particular flavor, that system that makes that very reminiscent. It's like, oh, I've gotten close to what I would buy.
All right, well, I'm happy with it. I feel like that I've learned what it should taste like.
I will probably go out to the store across the street and get like, what did I do wrong? What have we learned today?
That apparently I'm awesome at making boba.
Yeah, that's true. All of that's
kidding.
taking the edit. I think like kind of reviewing a little bit, right? I know we were asking a lot of questions about temperature here, and that has been important in terms of like trying to get to the right kind of consistency from the starter. There was a point where you're like, oh, this is great, and then it got slimy,
Yeah.
and it's not bad. It just became different. That's all.
Yeah, I would say, I mean, I feel like this is a really great story on like polymers in general because,
Love polymer.
and that the same polymer, right? What's really unique here is none of what we're doing is actually breaking any covalent bonds between the molecules.
Yeah.
It's changing the ability of the molecules to interact with one another. And that's why starch works to make our bubble tea or our boba pearls, as well as why starch thickens up gravies and those types of things because of its ability to absorb the water and change the texture. It's so interesting.
I think we learned a lot of valuable lessons. I think Julie gets an A. Daisy and I get a different letter that might not be an A, but that's okay.
You successfully made it in the
it's
end.
successful. We had a good time.
And I will say the thing that I've learned the most is I actually kind of like boba tea. Yeah.
That's the tea.
And that's the tea.
Okay. I think we can end there, folks.
Are we too old to say that?
No, we're not.
No.
We are not.
No.
I think
Okay.
this is a good
Maybe
transition
just
now.
me.